Hello everybody, so welcome to Supnits classes once again. So today we are going to discuss about bonding in coordination chemistry. So we are going to discuss, as you can see on your screen, that is NEET PYQs. So we have selected NEET PYQs on this topic today. From 1988 to 2026, all the questions has been covered. So if you do this, then all the PYQs, all the types of PYQs that has been asked in coordination compounds will be covered. If you need the PDF of this total question paper, you can do one thing. You can go to Play Store. Please write it down. Go to Play Store. There you can download our app Supnits classes. In that you will have a free study material section, and there you are going to get the PDFs of all the question papers that I am going to discuss time to time in this channel. Okay, so let us start our PYQs, in which we are going to not only solve the problems, but we are also going to understand the underlying concept behind that, so that our concept becomes super strong and we solve these questions very easily in our upcoming examination. So this is our first question. Okay, this is our first question. We are taking this. Actually, we are solving the total paper from bottom to top. So there is a specific requirement why I do so. Sometimes I do this in my classes also. Even I start this from class 9th and 10th. So let us see how does this help you guys. So without wasting any further time, we are going to start solving our questions. So this question was asked in 2026. ठीक है भाई? 2026 question. This is asked in 2026. So this is a simple question, UPAC nomenclature. So how to solve this? Many of you know. So whenever this kind of questions are given, don't look at the option, directly write down the formula by seeing the UPAC name. It is said tetraamine, okay. So tetraamine, I'll write aqua, that is H2O, that is also a ligand, and there is a chloridose, so Cl will also be a ligand, and that is going to, the metal atom is CO, CO3 plus, so that means 2 chlorine atoms will be outside, because this 3 chlorine atom is going to satisfy the oxidation state of cobalt 3 plus. Understood? So this is the answer. Now you check the answer. So this will be the option. So this is a very easy question asked in 2026. Okay, next question. 1:3 electrolyte solution. Now guys, how are you going to do this kind of question if it is said 1:3 electrolyte solution? So first of all, let us do the underlying concept in it. 1:3 solution means the cation to anion ratio, will be 1:3. Understood? Any of this is going to ionize in aqueous solution to give you certain cations and certain anion. So this cation to anion molar ratio will be 1:3 electrolyte. So here 1:3 electrolyte is this one. If you can see this, if this ionizes, then it will give CONH3 whole 6, because anything in the coordination sphere does not get out as ions, plus 3 Cl minus. So this gives you 1:3 electrolyte ratio. Clear? Next question. This is directly asked with respect to crystal field theory, the spectrochemical series. So please remember, you have to do a spectrochemical series. तुम सबको spectrochemical series याद रखना है, ठीक है? Everybody has to remember spectrochemical series. This is very important with respect to your crystal field theory and the total chapter of coordination chemistry. Please let me say this to all NEET aspirants. In NEET 2026, there has been 6 questions asked from coordination chemistry chapter. Yes guys, 6 questions. Re-NEET 2026, please go through that paper. There are, if you don't believe me, then there are total 6 questions asked from this chapter. Okay, so please ensure each and everything of this chapter is done quite carefully, and you will not get any shift in JEE Mains where this chapter has not been asked or question from this chapter has not been asked. So, in this, even if I don't remember spectrochemical series, this is a very easy question. I know in spectrochemical series, CO is a strong field ligand, CO is a SFL. Please write down, CO is a strong field ligand. ठीक है ना? So definitely this won't be correct, this won't be correct. Now coming to this one, see the first one and the last one is same for the both. So you just have to know which is stronger ligand, H2O or NH3. So NH3 is stronger ligand, so answer will be 3. ठीक है? Now, among the species given below, the spin only magnetic moment is highest for which one of this given? Okay, fine. So, how to do this? First of all, get out of your laziness. If you are lazy, you will not be able to solve these questions in your examination hall. You have to be proactive, you have to be active, you have to be agile. Okay, so let's be agile on this. Here it is cobalt 3 plus, here it is cobalt 3 plus. So normally what is cobalt? Normally what is cobalt? Normally cobalt is 3d7 4s2. Now when it is 3 plus, it becomes 3d6. Now 3d6. Now see, this is NH3. NH3 with cobalt behaves as strong field ligand. So you take this as strong field ligand. When you are taking this as strong field ligand, the it should be T2G 2, 2, 2 EG 0, 0, right? Because in case of strong field ligand, first the T2G orbitals are going to get filled up and then EG orbitals are going to get filled up. So here it is pretty clear to us that this has got filled up, and here we can see that number of unpaired electron is 0. So here the magnetic moment will be 0. Clear? Next question, Ti3 plus, titanium 3 plus. So titanium is nothing but 3d2 4s2. Okay, even if you don't know, here it is mentioned, so you can easily write down the electronic configuration. But those who are really serious about solving coordination chemistry question and also serious about their aspiration of clearing JEE mains and NEET examination, bhai, they have to do they will basically remember all this thing, 3d2 3d7 everything. The first transition series needs to be remembered with respect to electronic configuration. So this will be nothing but 3d1. So I don't need to see whether it's SFL or WFL. Here here number of unpaired electrons is equal to 1. Next, Mn3 plus, Mn with Cn. Okay, Mn is normally 3d5 4s2. When it is Mn3 plus, what it will be? It will be 3d4. It will be 3d4. Now it is SFL. Now it is with SFL. Cyanide ion is a strong field ligand. So it will be, there are 4 electrons. So T2G 2, 1, 1. There will be no filling of EG orbital. So here the n is equal to 2. Okay, here n is equal to 2. I think it's done. It will be this one only. Anyways, I'll check this one also. This is Fe3 plus, right? Fe3 plus. You know how to calculate this oxidation state. If you take this as x, this will be -1. So -6 is equal to -3. So x will be 3. Okay, so it is 3 plus. So normally iron is 3d6 4s2. Now when it is 3 plus, it will be 3d5. It will be 3d5 with SFL. It is 3d5 with SFL. That means T2G 2, 2, 1 EG will not be filled. So it is having unpaired electron is equal to 1. So maximum number of unpaired electron is available in case of Mn3 plus. So Mn3 plus will be having highest spin only magnetic quantum number. Okay, oh, sorry, magnetic moment. Fine with each and every one of you. You have to be in the game, guys. You have to be in the game. You have to remain agile during solving these questions. Okay. Next question. Which statement is incorrect? Nickel tetracarbonyl. I'll check this. Nickel tetracarbonyl. Okay. So nickel here is with an oxidation state of 0. Nickel here with an oxidation state of 0. So what I'll do is, this is nothing but nickel is 3d8 4s2. Now it is with an SFL. It is with an SFL. Carbon monoxide is a strong field ligand. So as it is with an SFL, So this will be uh, 3d8. Now this 4s, so I'll draw this to make you understand more, because otherwise it will be a problematic scenario. Okay, so here the configuration is like this normally. Okay, but as it is an SFL, the carbon monoxide will push this s electrons to pair it up. So this becomes 3d10 4s naught, making it sp3 hybridized and tetrahedral, right? And here the number of unpaired electron is 0, so this is diamagnetic. So it will be diamagnetic, it will be tetrahedral, it will be diamagnetic, it will be tetrahedral. So this is correct, this is correct. If this is correct, this cannot be correct, right? This cannot be correct. So this is the incorrect option. Okay, I should check it like this, because here I'll check A and C, because A and C is diametrically opposite basically. So if I check this nickel tetracarbonyl, my answer will come. Okay, done everyone? I'm going it a little bit fast because I expect that you know the chapter. Okay, next question. Which one of the following is paramagnetic? I have to find out which one of the following is paramagnetic. Very good, no problem. What I'll do is first chromium. Chromium is basically 24. Its electronic configuration is 3d5 4s1. It is having anomalous configuration. No? 4s to 3d4 should have been there, but anomalous configuration due to half filled orbitals in d subshell. So 3d5 4s1. So here it is a strong field ligand. So please write SFL. Please see how I am doing the problems. You have to do it in the same way. First the normal configuration, then write SFL. Then you have to put this is CR 0 only. So this oxidation number is 0. SFL means there will be pairing. SFL means there will be pairing. So this will be first of all 3d6 4s naught, because this CO is going to push this S electrons inside this. Okay. So this will be 3d6 with SFL will be 2 comma 2 comma 2 and EG will be 0 comma 0 and then 4s will be 0. So this will be D2sp3 hybridization, and this is diamagnetic because everything is paired. So this is diamagnetic, this is not paramagnetic, so this is not the answer. Let's go for iron pentacarbonyl. So here again iron is at 0 oxidation state. Iron is at 0 oxidation state. That means iron is at 3d6 4s2 configuration. It is SFL, it is SFL guys. So if it is SFL, so this will be like T2G, this will be like T2G 2 comma 2 comma 2, right? Now EG, I'll write this EG as, first of all I'll write this EG as 0 comma 0. Now it is 4s2. Now what is going to happen? This is SFL. What is SFL? This is CO is SFL. This is going to push, this is going to push these two electrons of s orbital into EG and make it 2 comma 0. This becomes 4s0, and there again you are going to find out this p. So the hybridization over here will be dsp3. There is no unpaired electron, no unpaired electron, n is equal to 0. So this is again diamagnetic, this is not paramagnetic. Let us go for this one, ferrocyanide ion. The iron will be 2 plus. Iron 2 plus means this is basically 3d6, nothing else. Now it is with a strong field ligand, so it will be T2G 2 comma 2 comma 2 EG00. Unpaired electron will be is equal to 0. So again it is diamagnetic, it is not going to help. You can check this or not check this, you can give this a tick. Cr3 plus, Cr3 plus means chromium 3d 5 4s are already written. 3 plus means one of the s and 2, so 3d3 will be there with a very weak field ligand over here. So 3d3 will be T2G 1 comma 1 comma 1. Here n is equal to 3. So if n is equal to 3 guys, it will be paramagnetic. Okay, done. Next question. Now here it is said that COF6 3 minus, number of unpaired electrons. First of all, please calculate the oxidation state. It will come 3. So this is CO3 plus. Normally cobalt is 3d7 4s2. Normally cobalt is 3d7 4s2. Now with CO3 plus it will become 3d6. It is a weak field ligand, so no pairing, so it should be T2G211 EG11. Okay, so this is total 6. You can fill up all this, right? You have to know how to fill up. I'll show this. T2GEG. First of all, 1 1 1, then 1 1 with weak field ligand. Then another electron is there. This is going to pair up. With strong field, first T2G is going to fill up and then EG is going to fill up. Okay. So how many unpaired electrons are there? 4. In octahedral structure D2sp3 octahedral structure, the pair of d orbitals involved is dx square minus y square and dz square. Why? Because these are axial ones. This can mix with p orbitals, px, py, pz. These are axial orbitals, that's why. Next, H2O weak field ligand, we know it very well, okay, but it is sometimes borderline, you know. So H2O is the ligand over here. You have to find out unpaired electrons, that is Mn2 plus. Okay, normally Mn is 3d5 4s2, Mn2 plus means 3d5. Okay, so this is a weak field ligand. So T2G EG will be filled like this: 1 1 1 1 1 5. Done. Easy question, right? See, this is very important question. This is very important question. Cn minus is a strong field ligand. This is due to the fact that it carries negative charge. It is carrying negative charge. It is a pseudo halide. This is the main point. Please write this down. Cn minus is a pseudo halide. Cn minus is a pseudo halide, and due to this reason they are strong coordinating ligand. Also they accept electron from metal. Okay, so basically it is a pseudo halide, that is why it can accept electrons from metal species. So you need to know the exact reason why Cn minus is a strong field ligand, then only this question you can answer correctly, otherwise it will be a difficult task. You can get -1. NiCO4, what is the hybridization? NiCN4 2 minus, what is the hybridization? And so I will give this as a homework. You can pause the video and check the answer. Answer will be B. I will urge you guys to pause the video and check the answer over here. Okay. Okay. Next question. Have you checked the answer? That one. Now do this one. Again, I'll say you to do it yourself because we have already done. What are inner orbital complex? Wherever you can see D2sp3 will be inner orbital and sp3d2 will be outer orbital. This is, again, you have to be agile and agile in doing this. The answer will be C, that I am saying you. Pause the video and solve this. Next question. Let us do this now. I hope you have done the last two homework on your own within this timeline. Okay. Here it is said what is the correct distribution of 3d electrons in chromium on this complex. Okay. So this is basically chromium H2O6 3 plus. If you see, this is the complex, right? So if this is the complex, then first of all I have to find out what is Cr3 plus. So Cr3 plus is 3d3. I have done it many times today only, so I remember now. Cr3 plus is 3d3. So as you all know, Cr3 plus is 3d3, so it will be simple T2G111. So T2G111 means this will be the answer. Okay, this will be the answer. Oh no, sorry. This is dz square. This will be the answer. Okay. D electron configuration, question number 40 over here. So D electron configuration. So this again I'll give you as homework, which will exhibit minimum paramagnetic behavior. So you have to find out the unpaired electrons. Unpaired electrons should be least. Unpaired electron should be least. The answer is 2. Answer is 2. Pause the video, solve the question. In case of any doubt, please comment in the comment section. Which of them will give the magnitude of del 0 to be maximum? See, magnitude of del 0 to be maximum, magnitude of del 0 to be maximum will be in case of the strongest ligand. So strongest ligand over here is this one. Again, the question is based on very simple application of spectrochemical series. So spectrochemical series is very important. Which gives highest paramagnetic character? So this one is good. This one is really good question. I'll do this. Okay. First of all, let us find out what is the oxidation state over here. X oxalate is having -2, so here it will be -4. OH again 2, so -2 should be is equal to -1. So X will be is equal to 5. X will be is equal to 5. Okay. Generally cobalt doesn't give +5. So anyways, I think something is wrong over here, but we have to do it like this. So cobalt is basically 3d7 4s2. From here if you take 5 electrons, then 2 3, so this will be 3d4, and this is having SFL, oxalate is an SFL, so it is having SFL, so this will be T2G 2 comma 1 comma 1, EG should be 0 0. So yes, this is paramagnetic, so this is paramagnetic where N is equal to 2. Now I will go to this Ti3 plus. So Ti3 plus, titanium 3 plus, titanium is 22. So basically it is 3d 2 4s2, 3 plus means 3d1. So it is clearly having number of unpaired electrons is equal to 1. Next is vanadium. Vanadium 5 plus. This will be 5 plus. You can check this out. This will be vanadium 5 plus. Vanadium 5 plus. So vanadium 5 plus is 3d0. Vanadium 5 plus is 23. Okay, this will be 3d0. Okay, and so and it is having all the weak field ligand with it, so N will be is equal to 0. Okay, this is again it is having En by pi, so this is a strong field ligand, and this will be Fe2 plus with SFL, Fe2 plus with SFL. So Fe2 plus is nothing but 3d6. Now 3d6 with SFL is T2G 2 comma 2 comma 2. So this will be N is equal to 0. Okay, this is a very good question. You have to work out, but it doesn't take much of a time. Anyways, here N is equal to 2 is this one. So this will be having highest paramagnetic behavior. Okay. Next question. Which of the following complex ions is expected to absorb visible light? Again, it is based on very intricate concept of color of coordination compounds based on application of CFT. So हम लोग अगर देखें कि CFT के एप्लीकेशन में जो कलर ऑफ द लाइट हम लोग पढ़ते हैं उसमें कौन कौन सा कॉम्प्लेक्स का कलर आता है. कॉम्प्लेक्स का कलर तब आएगा जब वो वेवलेंथ ऐसा आपके आंखों के सामने इमिट करेगा जो आपका विजिबल रेंज में पड़े. सो जिसका कलर आप देखोगे, जिसका कलर आप देख सकते हो, सपोज यू कैन सी ग्रीन कलर, यू कैन सी येलो कलर, लेकिन आप अगर व्हाइट कलर देख रहे हो इसका मतलब इट इज इमिटिंग कलर ऑफ वेवलेंथ विच इज नॉट इन योर विजिबल रीजन. ठीक है ना. सो वो एब्जॉर्ब भी वैसा ही कर रहा है. ठीक है ना. सो एक कलर का सर्कल होता है. सो कलर सर्कल के अंदर हमारा विजिबल लाइट का पूरा स्टोरी है. तो वायलेट, इंडिगो, ब्लू, उसका एक टोटल सर्कल होता है। सो मेरा क्वेश्चन ये यहाँ पर है कि इस इन चारों में से कौन सा कलर्ड है हमको ऑलरेडी पता है। सो इन चारों में से देखो क्रोमियम 3+ का जो ग्रीन कलर आता है ये हमको ऑलरेडी पता है। सो इसका मतलब इसका जो एब्जॉर्प्शन ऑफ विजिबल लाइट है दैट विल आल्सो बी कलर्ड, राइट? सो इट इज गोइंग टू absorb visible light, that is why I can see their color. If I am not absorbing visible light, you cannot see the color. So very simple, this will be this one. So this is basic factual question, easy question, basic factual question, easy question. Now let us find this out. Acha, coloredness species, we have to find out the coloredness species. So see, I don't have the values of CFSE over here. I really don't have the values of CFSE over here. Then what do I have with me? I do have the number of unpaired electrons. I do have whether they have unpaired electrons or not. किसी में अगर unpaired electron है, इसका मतलब उसका colored होने का probability है। जिसमें unpaired electron नहीं है, उसमें colored होने का probability कम रहते हैं। ठीक है? So ये general होता है। ठीक है? सबके लिए ये valid नहीं है, ये generally होता है। ठीक है? So हम लोग just इसमें check करेंगे कि इसमें colored है या नहीं है। एक एक करके करने का जरूरत नहीं, यहाँ पे डायरेक्ट करो। सो फर्स्ट ऑफ ऑल लेट अस डू TiF6 2-। सो यहाँ पे Ti कितना आएगा? Ti के ऊपर आएगा 4+, सो दिस विल बी टिटेनियम 4+। सो टिटेनियम 4+ इज nothing but argon configuration, so this is having number of unpaired electron is equal to 0, number of unpaired electron is equal to 0, right? So in that case it will not have any color, इसके पास कोई कलर नहीं होगा। अभी टिटेनियम का कितने ऑप्शन है? टिटेनियम की ये वाला ऑप्शन है, टिटेनियम की ये ऑप्शन है, तो इसका मतलब ये ऑप्शन तो नहीं होगा, ये ऑप्शन भी नहीं होगा। तो देखो Cu2Cl2 भी नहीं हो सकता, ठीक है ना, ये भी नहीं हो सकता। तो हम क्या करेंगे, हम इसको चेक नहीं करेंगे, हम इसको चेक नहीं करेंगे, पहले तो हम चेक नहीं करेंगे, ठीक है ना। पहले हम क्या करेंगे, NiCl4 2- को चेक करते हैं, ठीक है ना। NiCl4 2-, NiCl4 2- हम चेक करेंगे। इसमें Ni क्या होता है? Ni2+ रहता है इसमें, इसमें Ni2+ रहते हैं। सो 2+ अगर रहता है तो इसका मतलब ये है 3D8 कॉन्फ़िगरेशन विथ एन वीक फील्ड लिगेंड। तो 3D8 कॉन्फ़िगरेशन मतलब उसमें n=2 होगा, तो ये कलर्ड होगा। NiCl4 जहाँ जहाँ पे है ये डेफिनेट कलर्ड है, ये कलर्ड है, ये कलर्ड है, ये कलर्ड है, 100% कलर्ड है, ठीक है ना। तो फिर हमको क्या देखना है? अभी हमको देखना है Cu2Cl2 चेक करना है। तो Cu2Cl2 मतलब Cu+। तो Cu+ कैसे चेक करेंगे? Cu+ का होता है आपका 3D, Cu होता है 3D10 4s1, तो 3D10 होगा। यहाँ पे अगेन n=0 है, सो ये 100% कलरलेस है। Cu+ कलरलेस है, Ti4+ कलरलेस है। तो ये जो B वाला है, B वाला जो ऑप्शन है, ठीक से देखो, B वाला जो ऑप्शन है, यहाँ पे कलरलेस स्पीसीज चाहिए। सो B वाला ऑप्शन क्या होगा? B वाला ऑप्शन विल बी non-colored or it has no color. So B वाला option is the correct one over here. Answer is 2. ठीक है। Crystal field stabilization energy for high spin D4 octahedral complex. Crystal field stabilization energy for high spin D4 octahedral complex. So first of all we will write, sorry, D4. First of all we will write D4. D4 with high spin should be like this: T2G 2,1,1, EG 0,0. If there was no high spin, then it would have been D4 T2G 1,1,1 EG1 0, ठीक है। So this is what for high spin. Why I am writing it again? मैं क्यों लिखा है इसको फिर से? मैं इसको फिर से इसीलिए लिखा क्योंकि इसमें एक एक्स्ट्रा पेयरिंग हुआ है, ये जानने के लिए जरूरत है मुझे। कैसे जरूरत है? अभी पता चल जाएगा। यहाँ पे कितना इलेक्ट्रॉन है? यहाँ पे कितना इलेक्ट्रॉन है? ओहो, एक गलती हो गया भाई, जल्दी जल्दी में गलती, फिर से करते हैं, चलो सॉरी, हाई स्पिन बोला है, फिर से करते हैं, कोई प्रॉब्लम नहीं है, करते हैं चलो। हाई स्पिन मतलब इसमें है वीक फील्ड लिगेंड, ठीक है, वीक फील्ड लिगेंड है, स्ट्रॉन्ग फील्ड नहीं है, वीक फील्ड है, इसीलिए तो हाई स्पिन है, ज़्यादा पेयरिंग नहीं हो पाया। चलो देखते हैं अभी। सो जिसमें वीक फील्ड है उसमें पेयरिंग एनर्जी आएगा नहीं, क्योंकि कोई एक्स्ट्रा पेयरिंग का गॉल्प ही नहीं है, ठीक है। सो हम कैसे गोएंगे, लेट अस सी। See, here it should be T2G 1, 1, 1 EG 1, 0. So here it will be 0.4 into 3 डेलो प्लस 0.6 डेलो into 1, क्योंकि एक ही इलेक्ट्रॉन है, पेयरिंग एनर्जी कुछ है नहीं, तो इसी में गॉल्प खत्म। minus 1.2 plus 0.6, so this will be minus 0.6 डेलो, so this will be option D. Which of the complex ion should be expected, is not expected to absorb visible light? Excellent. Is not expected to absorb visible light. That means I have to find out over here a ion which is not having any unpaired electron, which is not having any unpaired electron. Let us check this. See, this is colored, I know this is colored, okay, this is colored, I have to check this two only, okay, this two, this one and this one. So let us first check this one, NiCN4 2 minus. So here nickel is at 2 plus, nickel 2 plus means 3D8 4s not. Now it is a strong field ligand. Strong field ligand will cause pairing 2, 2, 2, Eg will be paired 2, 0. ठीक है ना? Why it is paired? Here there is a thing to understand. Why here Eg is paired? Why Eg will be paired? You need to understand this. See, paired. Here if it is paired, then it can gain 4s4p dsp2 hybridization, and this is undergoing dsp2 hybridization. This is always dsp2, please remember this. Square planar, this is a strong field ligand, this is forcing this to pair over here, this is forcing this to pair over here. This is square planar, this has no, this is absolutely no unpaired electron, so it will be diamagnetic and it will not be expected to absorb any visible light. So this will be the answer. Okay. You can check this one also. NiH2O6. I should check this one also, right? Once. So this is again Ni2 plus 3D8 4s. See here there is no SFL, so there will not be any pairing. There will be unpaired electrons. So definitely this will be colored. This will be colored. This will be colored. This will be colored. Okay? Not expected. Not expected is this one. This one is not expected. Okay. Now coming to this one, 33. So how am I going to solve this one? Let us start this one. So this is first Ti3 plus. This is Ti3 plus. This is weak field ligand. Everywhere there is weak field, except you need to consider this cobalt as strong field ligand. Okay. Otherwise it is weak field. So Ti3 plus is nothing but 3D1. We have already done this. Please do it yourself. Do it yourself. नहीं तो नहीं हो पाएगा. ठीक है ना? So 3D1 is n is equal to 1. This is Cr3 plus. Cr3 plus is 3D3. 3D5 4s1 3 plus 3D3. So 3D3 weak field ligand n will be is equal to 3. Again this is CO3 plus. CO3 plus will be 3D6. So 3D6 with strong field ligand it will be 0 because T2G222, right? T2G222, remember Zn2 plus weak field ligand, Zn2 plus weak field ligand, Zn2 plus is nothing but 3D10, again n is equal to 0. Highest paramagnetic behavior will be shown by chromium NH3 whole 6. Okay. Now again the similar kind of question is there. So I would like you guys to solve this. Here the answer will be 3. Let's see this one. This one also very simple question. We have already done this. Here the answer will be 2. NiCN4 2 minus diamagnetic. Do you want to see this? We have done it or not? Here it is. NiCN4 2 minus. We have already done this. Give it a practice, guys. Okay. Now this is important. This is important. Red precipitate is obtained when ethanol solution of dimethyl dioxide is added to ammoniacal nickel 2. So which of the statement is not true? First of all, let us find out what is the uh, complex compound that is formed. So I will draw the complex compound. It's such a nice structure. So C CH3. Everyone draw please. O minus OH, and here it is HO and double bond C and O minus CH3 CH3. So this is a bidentate ligand. Nickel 2 plus. Okay. Here there is a hydrogen bonding. So what is asked? Red complex has square planar geometry. Red complex has square planar geometry. It is also said red complex has tetrahedral geometry. So either this is true or this is true. It has symmetrical hydrogen bonding. Yes, it has symmetrical hydrogen bonding. If you see, the hydrogen bonding at the top and the bottom is absolutely similar. Next, dimethyl glyoxime functions as bidentate ligand. That is also true. Here we can see that it is having square planar geometry is true. It does not have a tetrahedral geometry. Okay, it is not possible to have a tetrahedral geometry with this structure at all. Okay, so this is having only square planar geometry. This is a rosy red precipitate. Please write down. This is very important in qualitative analysis also. This is a rosy red precipitate. Next question, important question. D6. D6 low spin. Low spin means, please write down. Low spin means SFL. Now field T2G. D6 is 2, 2, 2. EG is 0. Now if it was not SFL, then it would have been T2G 2, 1, 1. Easy 1, 0. Clear? So extra pairing is 2 extra pairing. Let me just say you from where I have taken this question. This was one of the NEET PYQs. The answer was given wrong. I have corrected over here. Okay, and I have given you the correct options over here. Okay, so 2 extra pairing. Okay, so now it is minus 0.6 delo, sorry 0.4 delo into 6 electrons here. Here there will be nothing, plus 2p. So this will be, if you see this, minus 2.4 delo plus 2p. So this will be this one. This is the answer. Okay, important question, but we have done this kind of questions, right? It is not first time we are doing. Now, which one of the following is outer orbital complex and exhibits paramagnetic behavior? Very good. Outer orbital complex and paramagnetic. So outer orbital complex means sp3d2 and paramagnetic. So which cannot be paramagnetic? Let us first eliminate. See, Zn2 plus is 3d10. I know this very well. So this cannot be paramagnetic. This is out of. I am not going to check this again. Okay. This is likely to be paramagnetic. This is likely to be paramagnetic because this is, we know this is colored. Okay. So what I'll do is I'll check the Cr3 plus first, likely to be paramagnetic. Okay. So Cr3 plus, so Cr is normally 3d5 4s1. Now 3 plus means 3D3 3 3D 1 2 3 huh 3D3 3D3 means T2G 1 comma 1 comma 1 100% paramagnetic 100% paramagnetic, and if you see the EG orbitals are khali hai, so D2sp3, this is inner orbital complex. This will not be my answer. This will not be my answer. So I have to check others. I will. Now I'll again go to this one. Ni2 plus is 3D8. I know it is very well. With a weak field ligand, it will have 2 unpaired electron. Can you draw this yourself? T2GEG. First 1 1 1 1 1 1. Then this will be 2. This will be 2. So I think it's done. No, this will be 2. It is paramagnetic. It is paramagnetic, no problem. Now it doesn't have any option. It has to go to 4s not 4p and 4d for sp3d2 hybridization, that is outer orbital complex. So this will be the answer. I don't need to check any further. Which is diamagnetic? I think we should do this as an homework. Which is diamagnetic? This is pretty easy stuff. Okay, the answer will be 2. We already know, right? After doing, see, this is the important of doing MCQs. आप हम जितना MCQ करेंगे, जितना प्रैक्टिस करेंगे, उतना हमारा आइडिया और कॉन्फिडेंस बढ़ जाता है. एक हो जाता है कैसे MCQ को अप्रोच करना है, ये हम सीख जाते हैं. 1 नंबर. 2 नंबर, बहुत कुछ हमारा दिमाग में याद हो जाता है जो हमको एग्जाम के टाइम पे एलिमिनेट करने में मदद करते हैं. सो इसीलिए प्रैक्टिस इंपॉर्टेंट है. ठीक है, इसीलिए MCQ प्रैक्टिस इज वेरी इंपॉर्टेंट. गिविंग एग्जाम्स आर वेरी इंपॉर्टेंट. ठीक है ना. There are many places where they are going to give you lectures after lectures after lectures, but they are not going to make you exam ready, because you are going to feel good as long as you are not tested. When you are getting tested, then you are not going to feel good. So you are going to feel good, you are going to study, but at the end of the day, you are not exam ready. So do not only study, be also exam ready. That is our motto at Supnits classes. Which of the following, among the following, is paramagnetic? I think we should go this also as an homework. The answer will be this one. You can check this. This should go as a homework. D4 high spin. We have already done today D4 high spin, right? Let us do it again. D4 high spin means WFL. So it will be T2G111 EG1, that is minus 0.4 into 3 del O plus 0.6 into 1 del O. So this will be minus 1.2 del O plus 0.6 del O. This is minus 0.6 del O. ठीक है. So done na, right? Option B. Magnetic moment of 1. See, whenever you are getting this 1.73, you know this is root 3, and root 3 is only possible is n plus 2. So when it is possible? It is possible when number of unpaired electrons is equal to 1. So you have to just check which one has number of unpaired electrons is equal to 1. So guys, you need to check this. You need to check this. See, now the existing knowledge, I know this is diamagnetic. Don't need to check this. You don't need to check this. Existing knowledge helps, right? Now I'll do the Cu2 plus. So Cu2 plus, I know that Cu2 plus, you have to know this, DSP2. We have done this in class. DSP2 hybridization, please remember. Okay. So Cu2 plus, so this is 3D10, 4s1 is copper, so this will be Cu2 plus will be 3D9. So 3D9 should be like this. Okay, these are all paired, this is unpaired. So this unpaired is going to move there, so it is going to DSP2 hybridization, this is going to move out. Okay, this is going to move out, this unpaired is going to move out, and this has the unpaired electron. So the answer will be this one, that is fine, but there is locha in this compound. So I'll urge everyone to do this compound very well, because this is one that you need to remember. Okay. This question, जीरो क्रिस्टल फील्ड किस किस में है, वन विथ जीरो क्रिस्टल फील्ड स्टेबिलाईजेशन एनर्जी. लेट अस सी Mn3 plus, Mn3 plus, Mn3 plus, Mn is what, d5, d5 S2, right? Now you go for 3 plus, you will get like D3. Now D3 has unpaired electrons, D3 has T2G111, so it will have some crystal field stabilization energy. Crystal field stabilization energy comes in front of D0, comes in D5, comes in D10. D5 will be crystal field stabilization energy will be 0 only in case of WFL. Here and here always it will be 0. So, if there is anyone with D5 or D10, we need to check. So, here it is D5, Fe3 plus is D5, it is having WFL, so this will be the answer. This is how it helps us. If you remember the exact D5, D6, which is D5, which is D6, you can directly do this question without doing all those T2G, EG and all. So, you need to solve MCQs again I will be saying this. The hybridization involved in the complex, okay, I have already done this. Again, existing knowledge helps. You can see DsP2 NiCN4 2 minus has been asked multiple times. DsP2 diamagnetic, dimag बैठा लो. John Taylor, now this is out of syllabus. This is out of syllabus. I can say you the answer will be 2 over here, but this is out of syllabus. This was asked in NEET 2016 phase 2. You have to ignore this. Yes, I am saying you rightly. Don't get overwhelmed. No, इसको भी पढ़ेंगे हम सब पढ़ेंगे, सब पढ़ के जाएंगे. ये सब में घुसोगे तो असली काम नहीं हो पाएगा. ठीक है ना. NEET 2016 phase 2, many questions were there. I am saying you bluntly, which are above JEE level, which are above even JEE advanced level, I'll say, because it was out of syllabus. So John Taylor effect is absolutely not in syllabus. You need not do this. You can ignore this. Okay, absolute, you can ignore this. Now, as we are moving on to almost fag end of our lecture today, or PYQ solving session, I'll be giving you a lot of homeworks like this. Now, if you see, you have to find out the hybridization and the shape of this one. So, this will be definitely octahedral. इसमें क्या नया है, ठीक है ना? Definitely it will be octahedral. This will be 3d5 Mn, na? Mn3 plus 3d5 4s2. Now, this will be 3d4. So, 3d4 with SFL, 3d4 with SFL will be T2G 2, 1, 1. Correct. You also check that you are getting this one or not. Okay, 2, 1, 1. EG is completely empty. So, this will be D2 sp3. This will be octahedral. D2 sp3 octahedral. Yeah, khatam. I think you should do this as your homework. So, this is homework. Answer will be 2. Okay. See, this is octahedral, this is tetrahedral, everything else is same. You can use this formula. Tetrahedral crystal field stabilization energy is equal to 4 by 9 into octahedral. If you just do this, you are going to get 8000. Direct formula based. This is again very easy. This will be aluminium H2O. So, aluminium forms octahedral complex. We should know that. I have discussed this in my lectures. So, now I have to check whether this is this one or this one. So, I'll write Al3 plus, I'll write Al3 plus. So, Al3 plus is it is having argon configuration. So, argon configuration means no S, no P. So, this will be sp3d2. So, this will be the answer. Okay, I'll give this you as an homework, this to you guys. So, you will be able to do this, I know that. So, this will be answer will be 3. You can check this. Okay. Spectrochemical series, homework again. Spectrochemical series should be given as an homework. This will be 1. Next, should we do this, or we should go for this as an homework? I think we can do this as an homework. So, here the answer will be always try to find out if there is any option which is having different matching. So here C is having different matching. Just check C, don't check anything else. Just check C. C is Fe2 plus, that is 3D. Fe2 plus is 3D6 strong field ligand. So it will be T2G 2 comma 2 comma 2. So all are paired. So number of unpaired electron is 0. Magnetic moment will be 0. So it should be C2. Answer will be 1. Order of energy absorbed. Okay, I will help you in this. See, as chelation increases, CFSE increases. ठीक है ना? So as energy evolved increases, so lambda decreases. ठीक है ना? Lambda decreases. Order of energy absorbed. ठीक है? Order of energy absorbed. So here only energy is required, not lambda. Okay, fine. Only energy is required. So if energy is required, so maximum energy will be for C, then it will be for A, so it will be option C. Both. Okay, I'll give you this as an homework. Almost similar questions we have done many times today. So this will be, the answer will be 1. Correct order of wavelength, this is again, if CFSE increases then lambda will decrease. So order of wavelength is asked. So you have to see which is the strongest ligand. This is the strongest ligand. This will have highest energy. So lowest wavelength. So this will lie at the lowest point, that is B will be at the lowest. This 2 is correct. C will be at the highest because water is the weakest ligand over here. No, C will be at the highest. Wait. Wavelength of light has been asked. So if wavelength of the light absorbed, so energy wise, let me first arrange. Cn more than NH3 more than H2O6 more than H2O4. So lambda wise if I go, so this is Cn is your B more than A more than H2O6 is D more than H2O4 is C. So lambda wise it should be C less than D less than A less than B. So it will be this one. Okay. Which of this is paramagnetic? Again I'll give this as an homework. Number 10, the answer will be 1, A and D. So you have to check all of this over here. You have to check all of this. So that is the end of all the PYQs. We have gone through all types of PYQs asked in NEET examination. Okay, all the types of PYQs asked in NEET examination. So now it is time for you to understand the basic requirement, that is practice. So again, if you want to get the total PDF of this, you can get that in your Play Store, Supnits classes app, free study material section. You are going to get the PDF of this total PYQs, where from you can practice at your home. Thank you very much guys. Thank you very much.